Alright, for 9.7a, probability, we're first going to work with this term. A sample space is a set of all outcomes in an experiment. Any subcollection of a sample space is known as an event. Okay, so find the sample space for each of the following. 2 coins are tossed. Alright, well, S stands for my sample space. Then I'm going to use these brackets, which indicates set notation. And what are all the different types of outcomes when you toss 2 coins? Well, I could have a head and a head, a tail and a head and a tail, or 2 tails in brackets. Alright, so there's my sample space. I have 4 different outcomes. Alright, for the next one, we have the letters of the alphabet. A, B, C, D. Okay, you got the idea. And then we have W, X, Y, and Z. Okay, and that's your sample space for the letters of the alphabet. Next one, for a 6-sided die. Alright, well, you could end up with a 1, a 2, a 3, a 4, 5, or 6. Alright, for D, a coin is flipped once and a die is tossed once. Okay, so a coin is flipped once. So I could have a head and then roll a 1. I could have a head, roll a 2, head, roll a 3, head, roll a 4, head, roll a 5, head, roll a 6. And then I could go tails. Tails 1, tails and a 2, tails and a 3, tails and a 4, tails and a 5, tails and a 6. Alright. Alright, for the probability of an event. Alright, we're working with probability now. It's the number of event outcomes over the total number of outcomes in the sample space. Okay. So important, the probability of any event is always between 0 and 1. So if you're doing a probability problem and you're working it out, punching in your calculator, and you end up with something like 1.2 or 2.8, you're doing something wrong. Alright, the result should always be between 0 and 1. Alright, note you can state a probability as a fraction, decimal, or percentage. They're all different forms of stating the same quantity. Alright, example 2. 2 coins are tossed. What is the probability that one will land heads up and the other will land tails up? Alright, well, if we go back to the previous example with our sample space, we had heads, heads, tails, heads, heads, tails, tails, tails. Alright, and from that, 1 was a head and 1 was a tail, and we had 2 that were like that. We have tails, heads, and we have heads, tails. So it's 2 out of 4, which simply reduces to 1/2. And once again, you can state your answer as a fraction, as a decimal, or as a percentage. Alright, for part B, a card is drawn from a standard deck of playing cards. What is the probability that the card is a heart? Okay, this is where you have to know all the cards that are in a deck of cards. Alright, so there's 13 hearts in a deck of cards. Out of how many total? 52. Alright, so that reduces to 1/4. Then I get 0.25. And then I get 25%. Yeah, that's all there is to that. Example 3, 2 6-sided dice are tossed. What is the probability that the total of the 2 tosses is 5? Alright, now here we're looking at this chart here that shows the possible sums of rolling 2 dice at the same time. Alright, so for example, here I roll a 1 for the first die, I roll a 4 for the second die, and together they add up to 5. Alright, that's how you read this chart. So how many sums are there of 5? Okay, what is the probability that the total of the 2 tosses is 5? So I have 1 5 here, another 5 here, another 5 here. All right, I have 4 5s total. So there are 4 sums of 5 out of how many different sums? There are 36 total. So I end up with 1/9, which as a decimal is 0.11, or as a percentage, 11%. Done. For example 4, A class is given a list of 20 study problems from which 10 will be part of an upcoming exam. If a given student knows how to solve 17 of the problems, find the probability that the student will be able to correctly answer all 10 questions on the exam. Okay, the probability. All right, so from, let's see here. Okay, first thing you have to understand is what are the conditions for this problem. All right, well, there are 17 problems that the student does know, and out of the 20, and okay, and he's going to answer 10 of the questions correctly on the test. So there's 17 he knows. All right, this is a combination problem, and from those 17 you're going to choose 10 because he got 10 of the problems correct. So from those 17 there must have been 10 of them on the test. And here's a little side piece that you don't really need to include, but you're going to need to include in other problems, so I want to make sure I state this. All right, then if there are 17 problems he does know, how many problems does he not know? He doesn't know 3. And from those 3, how many are you choosing? You're choosing 0. All right, because none of the problems that you don't know are on the exam. Okay, and you're going to have to use this concept in future problems. So notice that 17 plus 3 is 20. That's the total number of problems to choose from. And 10 plus 0 is 10. That's the number of problems on the test. Okay, now since it's a probability problem, all right, on the bottom here, we're going to come up with a number of different orderings based on these conditions. So there's 20 problems total, and how many are you going to choose to put on the exam? 10. All right, so that's going to give you all the different possibilities for constructing exams. And now we have our probability here. So if we work this out, we get 0.10526, or it equals 2 over 19, or it equals 11%. Alrighty, the setup is the most important part. If you have any trouble with that, please make sure to ask for help. Alright, example 5. A college sends a survey to selected members of the class of 2000. Of the 1,354 people who graduated that year, 672 are female graduates and 682 are male graduates. If a graduate is selected at random, what is the probability that the person is female? Okay. So, let's see. We have 672 are female. Out of a total of how many? 1,354. Okay, super easy problem. All right, I'm already figuring out my probability that fast. All right, you just gotta know what you're doing. Very simple probability problem. Done. All right, for example 6, find the probability of drawing 2 marbles without replacement. It's a key idea. Both yellow from a bag containing 1 green, 2 yellow, and 3 red marbles. Okay, you could think of this as the 2-slot system. For this first slot, what is the probability that I choose a yellow marble? All right, well, there's 2 to choose from out of a total of how many? 6. Okay, and now for the second slot, I have to choose a yellow marble again. But keep in mind that when we chose the first marble, we didn't put it back. So now, how many yellow marbles do I have to choose from? I have 1 to choose from. But now, what's the total there is to choose from? There's 5. Okay, now we just multiply these. Get 2 over 30, which is 1 over 15. Okay, and you could rewrite that as a decimal or a percentage if you prefer. Doesn't matter. All right, that's all there is to it. All right, to get good at these problems, you just need to practice them, and then the concept begins to sink in, and it becomes easier to identify what strategies you need to use. All right, if you have any questions, please make sure to ask for help. Begin the assignment at the bottom of the page.